This is part 2 of adding and subtracting rational expressions. For the two rational expressions shown at the top of the video, we need to first start by factoring so that we can get a common denominator. So the first fraction is x plus 2 over x times x minus 2. And we're subtracting the fraction x plus 2 over 2 times x minus 2. Now for the common denominators, the second fraction has a factor of 2, which the first fraction is lacking, so we are going to multiply the first fraction by 2 over 2. And the second fraction has a factor of x that the second fraction is lacking, so we are going to multiply the second fraction by x over x. Our next step is to multiply the fractions. So we have, for the first fraction, 2 times x plus 2 divided by 2x times x minus 2. In the second fraction, we have x times x plus 2 times 2x times x minus 2. Now that we have a common denominator, we can combine them into one fraction by subtracting. So we have 2 times x plus 2 minus x times x plus 2, and that is all over 2x times x minus 2. I'm now going to distribute in the numerator, so we get 2x plus 4 minus x squared minus 2x, and that is all over 2x times x minus 2. The 2x and the minus 2x cancel in the numerator, so we are just left with negative x squared plus 4 divided by 2x times x minus 2. To factor the numerator, I'm going to pull out a negative so that it's x squared plus 4, x squared minus 4 divided by 2x times x minus 2. The numerator factors as x plus 2 times x minus 2, and that is still divided by 2x times x minus 2. Now that our fraction is completely factored, we can cancel the x minus 2 in the numerator and the x minus 2 in the denominator for a final answer of negative x plus 2 divided by 2x. The restrictions on our domain would be 0 and 2. If you want to try one subtraction problem on your own, you can pause the video now and try problem B. We're going to skip problem A. So for problem B, we need to factor the two rational expressions. So the first one is x minus 1 times x plus 5. The second one is x plus 3 divided by x plus 5 times x plus 1. To get common denominators, our first fraction is missing a factor of x plus 1, so we need to multiply by x plus 1 on top and on bottom. Now the two fractions have common denominators now, so we can multiply the x plus 1, x minus 1, and we can subtract x plus 3, and that is all over the common denominator of x plus 5 times x plus 1. Our next step in simplifying is multiplying out everything in the numerator. So that is x squared minus x plus x minus 1 minus x minus 3, and our denominator is unchanged. Combining like terms in the numerator, we get x squared minus x minus 4, and that is divided by x plus 5 times x plus 1. Since x squared minus x minus 4 does not factor, this is actually simplest form. So we are done and we need to specify our domain restrictions, which would be -1 and -5. The last type of problem we're looking at is adding and subtracting complex fractions, so fractions within fractions. So the way we go about this is start by isolating the numerator and adding the numerator so that the numerator becomes just one fraction. So to add 1/3 and 1/4, we need a common denominator, which would be 12. So we need to multiply the second fraction by 3/3 and the first fraction by 4/4. That gives us 4/12 plus 3/12. This is still all over 2/5. And that ends up being 7/12 over 2/5. And then to divide two fractions really means to take the top fraction and multiply by the reciprocal of the fraction in the denominator. So that means we are taking 7/12 and we're multiplying by the reciprocal of the denominator. So we're multiplying by 5 divided by 2. When you multiply those two fractions, you get 35 divided by 24, which can't be simplified anymore. So that is how we simplify that complex fraction. With polynomials, very similar idea, just now we have variables. So we are going to turn the numerator and denominator into single fractions. So our first fraction in the numerator has a denominator of x, the second has a denominator of y, and we need those to have common denominators. So we need to multiply the second fraction by x divided by x, and the first fraction by y divided by y, which gives us y divided by xy plus x squared divided by xy. So now we have a common denominator in our numerator. For the denominator, we have a fraction or a denominator of 1 over y, so we have a denominator of y, and we can rewrite 1 as y over y. So now we have 1 over y plus y over y. We can now add the fractions in the numerator, which becomes y plus x squared divided by xy. And in the denominator, we have 1 plus y divided by y. Now, in order to divide two fractions, that really means that we are taking the first fraction and we're multiplying by the reciprocal of the second fraction, the denominator fraction. So we are multiplying by y divided by 1 plus y. When we multiply these two fractions, we get y times y plus x squared. And in the denominator, we get xy times 1 plus y. We have a y in both numerator and denominator, so we can cancel that out. But nothing else here cancels, so we're left with y plus x squared divided by x times 1 plus y. We need to specify our domain for both x and y. So x cannot be 0 because of the x in the denominator. And y cannot be -1 because of the 1 plus y in the denominator. And y also cannot be 0 because of the y that we canceled out. So our final answer is y plus x squared over x times 1 plus y, where x can't be 0 and y cannot be -1 or 0.